So I was hoping we could take a look at some more fun exponential equations. So I'm going to get started with the first example. In here we have x minus 5 to the power 2 over 3 equals 27 to the power negative 1 over 9. So I added a few hints in here because I wanted you to try this on your own first. I hope you have already. But I am adding a few explanations to it as well, because why not? So the hint added in here is eliminate the power of the term with x on the base by bringing both sides to its reciprocal power. So what does that mean? So when you look at this equation in here, we have on the base, we have a variable x, and not only that, but the base is in binomial form, okay? And this is brought to the power of 2 over 3. And the other side contains only a constant term, 27 to the power of negative 1 over 9. So our focus should be on the unknown, or on the variable. So the variable is x, that's what we're trying to isolate here. And it is inside the base of some exponential number. So in order to gain access to this variable, what we need to do is eliminate the power. So what you must be thinking right now is think, okay, so what do I wish the power to be here so that I can have x more accessible, or more simplifiable? So you're probably thinking that the power of 1 actually would have helped the best to have in here, so that we can just have x minus 5 to the power 1. So the next thought would be, okay, so how the power is obviously not 1, so how do I make a power 2 over 3 into a power of 1? So I know that if I multiplied 2 over 3 by its reciprocal, 3 over 2, then this will become 1. But what operation do I have to apply to both sides of the equation that allows me to multiply power 2 over 3 by 3 over 2? So the only way to do this is by bringing this side to the power of 3 over 2, which tells us that we can now multiply the two powers, and we know that would equal 1. Now, if we do this to the left side of the equation, we must do the exact same thing to the other side. So that would be to the power of 3 over 2 as well. So now we are going to happily write the left side as x minus 5 to the power of, and I'm going to write this power because why not? So here we have the power of 2 over 3 that we had from before times 3 over 2. And the right side of the equation, and since we are in the power kind of fashion in here, we are going to write number 27 as a power of with base 3. So that would be 3 to the power 3 to the power of negative 1 over 9. We still have the negative 1 over 9 there. And to the power of 3 over 2. So on the left side, as you can see, we have now power 1. So x minus 5 is on the left side of this equation, equals, and now we have the power of the power of a power. So what happens to these powers is that they all multiply each other. So that would be 3 to the power of, and you can obviously do this in one step, but I'm just showing the work in here, the work we need to do. And we have 3 times negative 1 over 9 times 3 over 2. That would be 3 to the power of, so remember that the 3 and the 9 here will give a 3, so this will simplify, power negative half. Or you can simply evaluate this entire thing in a calculator. So, but it's a very simple exercise for to do just for the fun of it even. So this is what our equation has turned into. So as you can see, this is a linear equation because x is to the power of 1, and we have a bunch of constant terms in here, which means that we're going to leave x on one side and take all the other terms on the other side. So negative 5 becomes positive 5 on the other side, and plus 3 to the power of negative 1 over 2. This will be basically 1 over 3 to the power of a half, which is basically, again, 5 plus 1 over root of 3. So if we want to simplify this answer a little bit more, so what we want to do is multiply by root 3 over root 3, the number 5. So that will bring the first term to 5 root 3, okay, over root 3. and the other term would be 1 over root 3. So the answer would be x equals 5 root 3 plus 1 divided by root 3, and this would be the exact answer in this case. So in the next example, we have a different situation. So we see that we have in here a base of 2 to the power of 2x plus 3, that's a binomial power, minus 8 times 2 to the power of x plus 1, and then plus 1 equals 0. So we need to identify what type of equation this is. And the new thing that we see in here compared to the other examples is that we have binomial powers in two different terms. So I see that there are 3 terms in here. So I'm hoping that I can either combine these terms and leave the constant to the other, or maybe I can look for quadratic exponential equation. So I'm very happy to see that the base is 2 in both of them. And here you don't have a coefficient, here you have a coefficient -8. So I am sensing that since I cannot simplify, there is no rule that can help us subtract 2 exponential numbers even when they have the same base. So I am going to work on the exponents. So the reason why we have actually added these exponents is because we probably have had the base of 2 to the power of 2x multiplied by a base of 2 to the power of 3. So we are breaking this down into 2 to the power 2x times 2 to the power 3. So next we have minus 8. So this minus 8 we see in here. And again, we have 2 to the power of x plus 1, so that will be 2 to the power of x times 2 to the power of 1. So the power x plus 1 has come from the multiplication of 2 to the x times 2 to the power of 1. And then at the end, we have plus 1 in here and equals 0. So now we're going to take another look at this. So wherever you see numbers that you can evaluate, we will. So we have 2 to the power of 2x, and then multiplied by 2 to the power of 3. So 2 to the power of 3 is 8. And then we have minus, and pay close attention to this term in here. So 2 to the power of x is one of the factors. And then we have 8 and 2. Now, in multiplication, so because obviously we have multiplication between terms here, in multiplication the order doesn't matter. So we can multiply 8 by 2. So that would be equal to 16. So that 2 to the power 1, right? And then 2 to the power of x. And then we have plus 1 equals 0. So this time what I'm going to do is number 8, since it serves as a coefficient of this term, can be brought in here at the front. So 8 times 2 to the power of 2x minus 16 times 2 to the power of x plus 1 equals 0. So one last step. As you can see, we're getting closer to the shaping this equation into a quadratic exponential. So we have 8, then we have 2 to the power of x squared minus 16, 2 to the power of x plus 1 equals 0. And notice that now we ended up with 2 to the power of x, right, as our main variable for now. So this is to the power 2 with coefficient 8. Now we have 2 to the power of x with coefficient 16, and then plus 1. So if we use a helping variable here, the equation would look exactly quadratic. So we have 8a to the power of 2 minus 16 times a, and then plus 1 equals 0. So this is a quadratic equation. We're going to try to solve this as a quadratic equation. Let's see if it is factorable. So it can be factorable if we can find two numbers that multiply to 8 and add to negative 16. So two numbers that multiply to 8 and add to negative 16. So we are going to think of two negative numbers that multiply to 8. So negative 8, negative 1, negative 4, negative 2, that doesn't really work. So what we're going to do is try to use the quadratic formula. So we're going to say that a equals minus b, which is 16 in this case, plus or minus square root of 16 squared, well, basically negative 16 squared, minus 4 times 8 times 1. And that would be over 2 times 8. So we have 16 squared, which equals 256, minus 4 times 8 times 2, which is 32, is 224. So in a simpler form, then we're going to say that A equals 16 plus or minus 200, root of 224, and divide this by 16. So 224 can be reduced actually. It has, it can be broken down into 16 to 24, can be broken down into 16, and let's see what the other factor is. So I think it's 16 and 14. So here we get A equals 16 plus or minus root 16 root 14 over 16. So we are going to keep on simplifying. So the use of radicals, so simplifying radicals is very important here. So that's 16 plus minus 4 root 14 over 16. So as you can see, we can reduce the terms here by 4. And we have 16 over 4 is a 4 plus minus root 14 over 4. A lot of 4's in here. So what we have figured out so far is that we have two A values in this case. One would be at 4 plus root 14 over 4, and the other is 4 minus root 14 over 4. Okay, so as you can see, one is going to be, this one is going to be obviously a positive, and this is a positive as well, and x is in the exponent, so we don't have extraneous roots in this case, and we're going to say that both answers are acceptable, and these would be the solutions to this equation. All right, so in the next example, what we have is rational exponents. So when the exponents are in rational form and you have three different terms in the equation, what you want to try to do is express these exponents as doubles of each other. So for example, you would have in here x to the power of 4 over 3 as x to the power of 2 over 3 squared minus 13 times x to the power of 2 over 3, and then equals negative 36. Now, notice that this will turn out into a quadratic equation, or is shaping into a quadratic equation. So you have something squared minus a coefficient times that something plus 36, right? So you can tell here that we have just created a quadratic equation, which we are about to solve. And this would be in the form a squared minus 13a plus 36 equals 0. So factor, so 36 and negative 13. So what we have in here is a for both. So two numbers that multiply to positive 36 and add to negative 36 will be negative 9 and negative 4. So that means that a minus 9 equals 0, or a equals 9, or a minus 4 equals 0, which means a equals 4. So remember that a represents the x to the power of 2 over 3. So therefore, we're going to say that x to the power of 2 over 3 can be 9, or x to the power of 2 over 3 can be 4. So what that means is that to solve for x now, we need to release x from the power of 2 over 3. Remember how we did that before? Bring both sides of the equation to the power of 3 over 2. So, and that would leave x to the power of 1. 9 to the power of 3 over 2 will be the square root of 9 to the power of 3, basically. So that would equal 27. So square root of 9 is 3 to the power 3 is 27. So on the other hand, we have something similar here. We got to bring this to the power of 3 over 2, both sides. And now we have x equals 4 to the power of 3 over 2. Or in other words, the square root of 4 to the power 3. Square root of 4 is 2 to the power of 3 is 8. So the answer is 8. So the solutions in this case are at x equals 27 and at x equals 8. So I hope that you found these examples interesting and inspiring in a way. They do actually go to the next level in terms of difficulty, but nothing that you cannot do. So whenever you are encountering a new problem, what I suggest you do is you always keep an eye on the variable and try to imagine where the variable should be. Where would it be more accessible, easier to isolate? So when the variables are in the exponent, how do I bring them outside the exponent? When the variables are in brackets, how do I bring them outside the brackets, etc., etc.? So you have a couple more examples that you can try on your own, and they are pretty much similar to the examples we went over here. So hopefully you are going to find these examples useful and practical enough and easy enough to follow to solve the rest of the equations. So thank you for learning with me, and have fun practicing more. Bye for now.